Hey everybody, how y'all doing today? So I got a problem for us that's going to be a good one. So I'm looking at the function y is equal to 1 over x, and I want to try to approximate the area from 1 to 2 using 5 equally spaced rectangles. Look here, I got 5 equally spaced rectangles. And I want to know something interesting. Look here, I have a function that is always decreasing. It never increases. It's consistently and always decreasing. So one thing I noticed is if I want to look at an upper approximation, an area that is more, I'm going to actually be using these left endpoints. Okay, so that's something good to note. And if I want a lower approximation, something that's less, in this case, because I'm always decreasing, I'm using a right endpoint. So a couple of things to notice. I'm looking at the summation from 1 to 5, f of c times delta x. Well, my delta x is, of course, going to be b minus a over n, which is 2 minus 1 over 5, or 1/5. Yeah, I wrote it twice. That's how important it is. And then the left endpoint ci is going to be, of course, my a plus I minus 1 times delta x, because I'm starting 1 previous. I'm not actually adding any amounts. My first rectangle will be just this a height. So we have this 1 plus I minus 1 over 5. And my right endpoint is going to be, of course, my a plus I delta x, where I'm taking my a value of 1 and I'm adding a delta x every single time. So I'm adding 1 over 5 every time. That's why we use the I. Alright, so let's dive into this. Alright, so if you try to take your left endpoint approximation algebraically, you can, but at some point you're going to get like a summation of 1 over I. And even if you're smart, you'll try to like manipulate this to like I to the negative 1, but we don't know a summation formula that involves I to the negative 1. We know the summation formula of a constant, of an I squared, an I cubed, but not an I negative 1. So I'm going to look at this very rudimentary. My left endpoints are going to exist at 1. 1 plus a 1/5, so 6/5. Plus 2/5 would be 7/5. Plus 3/5 would be 8/5. And then my last endpoint is going to be over here at 9/5. That's a 9, I promise. Just like that's a 6. Oh, that's so bad. I'm so sorry, guys. Alright, that's a 6. And this is a 9. Okay? This is a 9. It won't let me erase it. Oh well. Just trust me. Alright, so if I plug all of these values into my function, my 1 over x function, well, 1 over 1 is just 1. 1 over 6/5 is 5/6. 1 over 7/5 is, well, you get it, it's 5/7, 5/8, and 5/9. Again, I'm taking 1 divided by a fraction, usually 1 multiplying by the reciprocal. Okay? So if I have all of that, and I'm going to shrink some things down, give me some room. Let's start adding them up. Remember, these are my corresponding heights, right? If we look at all these values I just have, these are the heights of my rectangles. And what's the width? Well, my width is going to equal 1/5. It's my delta x. So let's do 1 times 1/5 is 1/5. 1/5 times 5/6 is 1/6. 1/5 times 5/7 is 1/7, and so on and so forth. Okay, it's kind of cool how that worked out. So if we add all these up, we get 0.746. Okay, and that's my upper approximation. That's the area that's more. It's like more than what I actually deserve. Okay, well, very similarly, let's look at the lower approximation. If you were to do the same thing, try to do this algebraically. Okay, you're going to have this like 1 over I to the 5th, and at some point you're going to break down to just a 1 over I, or of course like an I to the negative 1, and you're going to be like, wait a minute, I have no idea how to do that. It's just, we don't have a summation formula. So let's break it down piece by piece. Of course, my function is 1 over x. Now, my right endpoints are all going to be those previous endpoints we had shifted by 1/5. So instead of starting at 1, we're going to start at 6/5. And then so on and so forth. 7/5, 8/5, 9/5. And we're actually going to make it all the way to 10/5. The thing about 10/5 is that 2, which is that right side bound we had. Okay? I'm going to leave it at 10/5 because it's kind of convenient for me. So when I plug this in, this is 1 divided by 6/5, or 1 multiplied by 5/6, 1 multiplied by 5/7, 5/8. You kind of get the idea. Okay? These are my corresponding heights. Do we agree, class? I think we should agree. This is the height of my rectangles. Okay? Where the width is all just going to be 1/5. So if I start multiplying them, well, 1/5 times 5/6, and I'll show that in case you didn't see it before. 1/5 times this 5/6, conveniently it's going to equal 1/6. 1/5 times 5/7 is 1/7, and you can kind of catch the pattern. And that's why I left it as 5/10, so I can see those 5's canceling. And I get my lower approximation to be 0.646. So that was my lower approximation, okay? So remember, when we're doing these approximations of areas, left or right-sided, yeah, we have our summation formulas, but don't forget the very basic concept of what you're doing. Alright guys, that's all I got for y'all today. Again, if you need me, email me, tweet me, Edmodo, all those places. Y'all have a good day.